So here's an example of a limiting reactant problem that you might encounter. Let's say we're looking at the industrial production of ammonia, which is NH3, this molecule right here. This is a really important industrial molecule because it is a molecule that's used to make fertilizer, and without the production of ammonia, we couldn't produce enough fertilizer to feed all the people that are alive on the Earth. So the discovery of this process to convert nitrogen and hydrogen into ammonia was a really important discovery back in the early 1900s. So this is a reaction that's commonly done at high temperature and high pressure with a catalyst. We'll talk about catalysts eventually in this class to produce this. But let's say we have a situation where we have 6 kilograms of nitrogen and 6 kilograms of hydrogen in their gaseous forms, and we want to know which of these is going to limit how much ammonia we produce. So this is the example of the sort of question you might answer with a limiting reactant question like this. Okay, and the approach we're going to take is we're going to figure out how much ammonia can we produce from each of these reactants. So we're going to need to convert these into moles and then use the ratio here from the balanced chemical equation to figure out how many moles, or even grams, we'll figure out as grams, but moles or grams of ammonia we're going to produce. So we need the molecular mass for nitrogen. That's going to be 2 times the value from the periodic table, which I have right here at 14.007, which is equal to 28.014 grams per mole. And then we're going to need the molar mass of hydrogen, which is 2 times 1.008, which is equal to 2.016 grams per mole. Okay, so let's figure out how much is 6 kilograms of nitrogen in terms of moles. So I'm going to set this up as sort of one long calculation. So we're going to go straight from grams of nitrogen, kilograms of nitrogen, directly to moles of ammonia. So this is a multi-step problem, and we're going to do sort of the multi-steps all in different fractions. So we're going to start with 6.0 kilograms of nitrogen, and we're going to do the unit conversion. So for every 1 kilogram, there's 1,000 grams. And then we need to use the molar mass here. So we're going to divide by grams to 28.014 grams, and moles is going to go in the numerator here. And then from the balanced chemical equation, we know that for every 1 mole of nitrogen, we produce 2 moles of ammonia. So again, just checking our units, kilograms cancel, grams cancel, moles of nitrogen cancel. We should be explicit here, this is nitrogen here. And we can get directly to moles of ammonia. So let's go ahead and plug that into our calculator here. 6 times 1,000 divided by 28.014 times 2 gives us 428.4 moles of ammonia. And we could have gone one step further and calculated the grams of ammonia. Either way, you can either compare the moles or you can compare the grams. Either one will be able to tell you which one is the limiting reactant. All right, and then we can repeat that same calculation but use our hydrogen. And since we started with the same mass, that's what we're going to start with here, 6.00 kilograms of hydrogen. So this unit conversion is the same, 1,000 grams for every kilogram. Our molar mass is now different, 2.016 grams per every mole of H2. And our stoichiometric factor here from the balanced chemical equation is different as well. It takes 3 moles of hydrogen gas to produce 2 moles of ammonia gas. All right, so we have 3 moles of hydrogen for every 2 moles of ammonia. All right, and then we can put this into the calculator. So we get 6 times 1,000 divided by 2.016 times 2 over 3 gives us 1,984 moles of NH3. Okay, so what we can see here is that our limiting reactant is nitrogen. because it produces less ammonia if we let this reaction go to completion. Right, and so if this reaction proceeds at 100% yield, so all of the nitrogen reacts and forms ammonia, we would expect to get 428.4 moles of ammonia. We can convert that to grams if we want to. So the answer to this question, which one of these is limiting us, is the limitation is nitrogen. So the next thing we're going to look at in the subsequent videos is the idea of a percent yield. All the calculations we've done up to this point have assumed that our reaction behaves perfectly, and all of the products turn into all the reactants turn into products that can. But in real life, there are inefficiencies. There are things with the reactions that lead to the reaction not going at 100% yield, meaning not every reactant is turned into a product. And so we'll go into how to calculate what is the percent yield of a reaction.